All right, so here's a fourth example, and I'm hoping that after those first three, you're going to start to see how the images start looking and how you can decide between the laws and just the approach that you would take to pretty much solve any of these, because it's really meant not to be new information. It's just meant to be applications of the formulas that we are learning. So in this case, it says a boat leaves a pier heading due north for 50 miles. So hopefully we all know our compass, right? This is north, south, east, west, north, south, east, west, right? So they're telling us that to start off, we have a boat. So I'll call this boat. And the boat is going north for 50 miles. So, okay, let's just say there. Okay, so that's our first 50 miles. Then it says the captain then turns 20 degrees towards the west. So west is towards the left. So again, we have a similar scenario to that plane example. So remember we said this is the path that it would have kept going on, right? That pink path. But it ended up going a little bit west. So this is 20 degrees. And again, similar to that first example, we could also figure out this angle in here, right? Using the same approach we did on example 3. These two angles should add up to 180, right? So if I already know 20 of it, then I can do 180 minus 20, and that'll tell me that angle right there. And I can finish it off from here to there. And the question is saying, let's keep reading. Oh, and goes another 10 miles. So let me add 10 to this. So it's going 10 miles. And then it says, at this point, the boat breaks down. Oh, man. So the boat is stranded. So let me draw a little stranded boat. Help. It's stranded. What angle? So notice the question says, what angle? Oh, oops. What angle, right, from north? So pretty much here. Which angle? Does the harbor need to send a tugboat? So they're going to pretty much do like a tow truck on this boat. So they're pretty much saying if this is the harbor, this is where it starts, what angle would I have to send it out to reach the boat? So we're trying to find this variable x. Okay, so let me blow up our picture really quick. So it looks like we have something like that, something like that, something like that. And then inside of the thing we have 160, we have 10, we have 50, and we want to know this, right? Okay, so in our head we're thinking law of sine, law of cosine, law of sine, law of cosine. If I try the sine law, if I try the sine law, I can do this with this, right? But notice that I can't really match anything else. So this side would go with this angle, which I don't know. And this angle would go with this side, which I don't know. So I have too many unknowns to use the law of sines. So then we're like, okay, no biggie. So get rid of those unknowns. Could I use the law of cosine? Well, again, if your goal is to find a missing angle, you would need to know the third side, which also makes it difficult because we have two unknowns. So what we're going to do is we're going to see if we can use the law to figure out one of the unknowns that would allow us to figure out that missing angle. So I'm actually going to call this side y. And notice I could use the law of cosines to figure out that missing side. So I'm going to say, and also notice that Also notice that this angle, right, would be linked to this side. So I'm going to say y squared is equal to 10 squared plus 50 squared minus 2 times 10 times 50 cosine 160. And let's see, I'm going to cheat, so let me go up to where I already solved it. This one. So if I do, yeah, so it's going to be 353969. 353969. 3539.69. And if I take the square root, because I got to get rid of that square, then that distance is going to be 59.5 miles. So pretty close. 59.5 miles. Oops. 59.5 miles. Okay. So now I know this. So this is 59.5 miles. So why is that helpful? Well, if I re-envision my triangle a bit, oops, there. So if I re-envision my triangle a bit and I replace the things I want to know, so my ultimate goal is to get this angle down here. I now know that this is 59.5. I already knew that was 10, and I already knew that was 50, and I already knew that angle was 160. So now you can see that I put myself in a good enough position to figure out that missing angle using either the sine law or the cosine law. So I'm actually going to use the sine law just to practice both, but just keep in mind the cosine law could also be used here. So how does the sine law work? So I'm going to match up the things. So this angle is going to match up with that side, the one across, and this side is going to match up with that angle. So I know exactly enough information to use the sine law. So let's see, this is going to be sine of 160 over 59.5 is equal to sine of x over 10. So if I cross multiply, I'm going to get these matching, these matching. So then I'll get 10 sine 160 is equal to 59.5 sine x. And my goal is to get that alone, the sine x. So I'm going to divide by 59.5. And this will turn into a big number 1. And then let me cheat real quick. I already solved it. Where are you? So the angle ends up being 0.057. I mean the division, the ratio ends up being 0.057. So I get 0.057 is equal to sine x, right? And I want just access to the variable. So I'm going to get rid of sine. And I can do that two ways. So remember we talked about sine inverse, or I introduced you to this thing called arcsine. They literally are the same thing, but just for practice, I'm gonna use arcsine this time. So those will go away. So my angle is gonna be the arc sine of 0.057, which I think I already remember because I looked at it a little while ago, and then ends up being 3.27, which should make sense. This angle is not super big, so 3.27 degrees. So they would need to send whatever rescue team out 3.27 degrees to reach the boat that they need to rescue.